An alien force stalks the Earth with the power to cripple civilization.
A solar flare was released from the sun yesterday was accompanied by a second and potentially more serious event known as a coronal mass ejection.
A giant storm explodes on the sun with the power of 1 billion hydrogen bombs.
Scientists believe that it may impact Earth. The public is being asked to stay on alert.
A solar bomb that will paralyze modern technology and send us back to the steam age. We know that a storm like this can happen. It's happened before. In the power center of the United States of America, a star chamber of top scientists and policymakers meets to discuss the sun. They're sharing new research about an event that could destroy technology on Earth and threaten the lives of millions. A storm from the sun that can erupt when solar activity peaks.
We're just getting to the point that we are now understanding that space weather may be, in fact, the largest natural disaster that could occur.
The scientists are speculating on what could happen if a massive solar storm came down to Earth.
Your internet goes out, your cell phone goes out, your light goes out, and you go, oh my God.
And they've a platform to build from because it's happened before. On September the 1st, 1859, English astronomer Richard Carrington recorded an astonishing event. Astronomer and historian Stuart Clark has spent years analyzing Carrington's findings.
Every clear day, he comes into his observatory and sets up his telescope, and then spends hours sketching what he sees in the most precise detail. He then spends hours calculating. In the 19th century, that's what he has to do if he's going to make any discoveries. Carrington is obsessed with the sunspots, and he believes if he can understand them, he can understand what's happening inside the sun. That compulsion is about to pay off.
Sunspots are dark patches on the sun's surface indicating areas of intense magnetic activity. But in 1859, Carrington knew them only as mysterious patterns that constantly changed. And as he watched them on September the 1st, they were bulging to 10 times the size of the Earth. Then, without warning, two intensely bright beams of light appear above the sunspots. Blasts like colossal nuclear explosions that lasted for 5 minutes before vanishing from Carrington's view.
Whatever's happening on the sun, the power behind it is tremendous.
As quickly as they appeared, so they disappeared. And that's when it hit him. Who on earth was going to believe this? The blasts were coming from the sun's fiery halo, its corona, the sun's superheated atmosphere. A place where gases sizzle at 2 million degrees Celsius. A place so hot that atoms are ripped apart, sending plasma blasting out across the solar system in a steady shower of particles called solar winds. And sometimes the sun's corona erupts with a colossal burst of energy, a coronal mass ejection, spewing up billions of tons of blistering plasma from its surface. A fiery expulsion that whips the solar wind into a hurricane-like frenzy, creating danger to life on Earth. That's what Carrington saw. Contemporary scientists have spent decades studying space weather, the name given to radiation from the sun and other stars. But they did not realize the threat a sunstorm posed until recently. Until we better understand the sun, we won't be able to protect ourselves from its fire. But ironically, one of the best times to study it is when it's hidden from our view, in a solar eclipse. Professor Jay Pasakoff is an eclipse expert.
I'm going to take a look at sunrise, see if I can see anything in the east.
He and his team chase this cosmic phenomenon all over the globe. And the thing he really needs is a clear sky.
Well, I see structure in the clouds. That's better than solid clouds. We will see.
Pasakoff of Williams College, Massachusetts, has brought his team to China, where he believes he has the best chance to monitor the longest total eclipse of the 21st century.
This will be my 28th total solar eclipse out of my 49th eclipse altogether.
A total solar eclipse is when the moon passes directly in front of the sun, dimming its brilliance. At totality, the sun's outer atmosphere is clearly visible. The corona, a halo of fire outlining the moon.
Eclipses are very rare opportunities to study certain parts of the sun. If you were a heart surgeon and I said, you've got to go to Africa to get a look at the inside of a heart for 3 minutes or 5 minutes, and then you have to wait a year and a half to do it again, you'd go.
A total eclipse is the perfect opportunity for Pasakoff to spot clues about how the sun really works. And this one offers one of the best chances in his lifetime.
We only have a few minutes to study this part of the sun, and every time we learn something more, and it all adds up to improving our understanding.
The mystery Pasakoff wants to solve is why the sun's corona sizzles at 2 million degrees Celsius when the sun itself is burning at only 6,000.
But when I look up at the sun now, I see the everyday surface of the sun. You know that if you have a hot stove and you're too hot and you walk away, it gets cooler. Whereas on the everyday sun, if you walk away or you move away, it gets hotter. And that's what we're investigating.
It defies common sense, as if the air in the kitchen were hotter than the stove. So what is causing the corona to superheat? The answer to this mystery affects us all.
It's critically important to understand what's going on in the corona because that's the reservoir of gas from which these huge coronal mass ejections are erupted.
Astronomer Stuart Clark is also in China for the eclipse. But he's with the masses on the banks of a river in the lowlands.
At the moment of totality, you get a few minutes of seeing the outer atmosphere of the sun. So this is your time to try and take a peek at something you can't naturally see at any other time. And in those moments, you never know whether you will be the one that sees the clue to make it all make sense.
At 6 minutes and 39 seconds, today's eclipse will be the longest totality for 100 years. A chance to solve one of the biggest mysteries of science. Pasakoff's team is focused on the atmosphere just above the solar surface, ready to pounce on telltale signs of colossal heat pumping into the corona.
That million-degree gas may oscillate a little bit in brightness. We're interpreting that as a sign of how the corona gets to be very hot. I can see the full sun now. Okay. No sunspots, of course. Well, here's a little cloud in front of the sun, but I'm seeing the whole distance. 15 seconds to first contact.
First contact. The moon starts to nibble the sun. One thing stands between Pasakoff and understanding the sun's corona. That's weather on the Earth.
Not looking too encouraging at this very moment.
Thick cloud cover threatens disaster. Until scientists decipher the inner workings of the corona, it's impossible to predict when the next big Carrington event will occur. And Clark can only imagine the havoc it would wreak on our technological world. Clark sets his disaster scenario at the scene of an eclipse.
At the moment that the moon covers the sun, so we see the ghostly outer atmosphere of the sun, the corona. And for much of astronomical history, the eclipses were the only time you could ever see this. And this mysterious outer atmosphere continues to defy our understanding even today.
We're about 60 seconds to totality.
I'm gonna call my dad. That's good. I really wanted him to be here, but he had to work. Dad, no, I'm standing right here. Yeah, you should be here. Okay, I'm gonna send a picture to you. Hold on. Okay, I sent it.
Hey guys, come take a look at this. Jay sent some photos of the eclipse.
Wow, that's nice. Wow, that's cool. Oh, look at the background, eh?
Yeah.
If the flare took place directly aimed at the Earth during an eclipse, you wouldn't see it directly because the moon is in your way and blocking it. The first you would know is as the moon moved away and you saw this gigantic halo of boiling gas coming towards you.
Did you see this?
We're getting massive readings coming through. Massive readings. We just had a major spike.
Go satellite?
1 billion tons of gas can just be thrown off, and that lumbers through space behind the flare and can arrive anything between 18 and 36 hours later.
Dad? Hello? Hello? Is your cell phone working?
No, it's just like dead.
No, I don't have any service.
At the moment that the flare goes off, they can start calculating the power of the flare itself. It's likely to be something like a billion times the energy released from an atomic bomb.
We're reporting a CME at 13:08 hours. Confirmed? Yep, we had already registered a massive radiation spike on the GO satellite. This looks big, very big.
When you've got one of these coronal mass ejections coming at you, the clock is ticking every second.
There have been 5 major coronal mass ejections in the past 150 years, and no power on Earth could shield our planet against one like Carrington witnessed. 15 minutes may be all the warning we get. This is the Space Weather Prediction Center in Boulder, Colorado. It's the souped-up weather station that can spot sudden spikes in solar radiation. The people who work here monitor the sun 24/7 to give us as much warning as possible of impending disaster.
No space weather storms were observed for the past 24 hours. No space weather storms are expected for the next 24 hours.
Sudden increases in solar radiation can affect satellites and electrical grids, and endanger astronauts as well as aircrew and passengers. The SWPC forecasts space weather so that vulnerable technology and people can be better protected against its effects. If an 1859-sized storm blasts the planet, this will likely be the first place on Earth to see it coming.
If a solar flare goes off, the activities in this room would immediately become sharply focused in assessing the size, or what we think to be the behavior of the flare. Is it still increasing, or has it reached its maximum? But what you would see in here is a frenzy to try to understand as best you can what's going on, and then getting the word out to people that need to know. Questions are, has a coronal mass ejection occurred as a part of this eruption? And if one has, we'll be able to see the white material, the reflection of the sunlight off the electrons in this image, to tell the forecaster that yes, part of the solar atmosphere has been blown away. And now it's a ballistic problem. Where's it going? Are we in the path or not? For forecasters, that's the white knuckle time.
Yeah, take care.
Court Williamson is the center's operational specialist. He's been predicting space weather for over 10 years.
When is your next launch on a shuttle? A CME? Makes all of us nervous. You know, that's the reason you put on a tin hat. I don't think we're prepared psychologically. I don't think we're prepared culturally. And I don't think we're prepared technologically for an extreme solar event.
Sometimes you need the bad thing to happen to wake people up, to make them realize that they have to pay better attention to it.
It's not if, but when.
The Earth's watchdogs are 5 satellites that monitor the cosmos for coronal mass ejections. The first detects the telltale blast of X-rays from a solar explosion in the sun. Then a pair of satellites called Stereo captures the CME in 3 dimensions, a chilling snapshot of monstrous size, shape, and speed. The next looks for the halo of light that says a CME is coming straight at us. Earth's last guardian is the ACE satellite. It risks destruction in the hail of particles to calculate if, when, and how hard the CME will hit. By then, it may be 15 minutes or less until impact. In 1859, the first warning signs of disaster meant it was already too late. 18 hours after Carrington witnessed the sun's flares, the skies were filled with an angry beauty, the northern lights, Aurora Borealis. Evidence that the Earth's magnetic field was battling radiation pouring down on us from the sun.
If you live in Canada, or Norway or Russia, the chances are you've seen the northern lights, but not like this. This is something far more intense. From the north, the lights are marching downwards towards the equator. Boston, Florida, Jamaica, Cuba.
All over the night side of the planet, people watch in horror as the skies turn deep shades of green and violet, then a spectacular angry red.
At the same time, from the south, they're springing upwards. In the Pacific, sailors see the most terrifying display in the sky. People think the world is coming to an end.
The Earth is in the grip of an all-powerful aurora, twisting the planet's magnetic field. All over the globe, compass needles are going haywire.
Something's pulling the Earth's magnetic field in all directions.
News of the strange event is spread by the 19th century's forerunner of the internet, the telegraph.
For the first time in history, we're developing a global network of telegraph lines carrying signals across North America and Europe.
It's a vast grid of electrical communications, the beginning of a new technological society. The perfect hunting ground for an alien force.
The Boston telegraph operator discovers that if he disconnects the wires from the battery, he can still send signals, powered only by the phantom electricity from the aurora.
The sudden massive surge of current shocks a telegraph operator in Philadelphia and starts fires in telegraph stations all over America. The sun pulled the trigger. raining missiles on Earth at more than 8 million kilometers per hour. In 1859, the telegraph was the only technology vulnerable to solar storms. In 1989, a solar storm 1/5 the size of the Carrington event shut down the entire electrical service for Quebec, Canada. 6 million people lost power in 92 seconds. We depend on technology, and our lifeblood is electrical power.
We're interrupting this program to bring you a special news alert. We've been told that this is a nationwide news alert directed by the White House in consultation with Homeland Security. According to NASA satellite images and data, a solar flare, which was released from the sun yesterday and which was responsible for widespread disruptions to wireless technology, from cell phones to GPS,
Hey guys,
was accompanied by a second and potentially more serious event known as a coronal mass ejection, an expulsion of billions of tons of plasma from the surface of the sun. Scientists believe that it may impact Earth, and the public is being asked to stay on alert. We will continue to provide updates throughout the evening.
The solar storm that Stuart Clark imagined erupting during an eclipse is getting closer to Earth. The eclipse may be over, but the danger is just beginning.
The Earth's magnetic field is like a natural shield, and with the normal wind of particles that comes from the sun, it's more than capable of deflecting those. One of these CMEs, however, is generating its own much more powerful magnetic field, and the Earth can't win against that.
Geomagnetic storm is imminent. We have a national emergency condition red. Condition red.
This presents an unprecedented threat to our power grids, and the public is being warned to expect severe communication disruptions and electricity disruptions.
Can you turn that up?
It is not known at this time how widespread the damage will be, or how extensive or how long it will take normal services to resume. People are being asked to stay calm.
An event like 1859 could plunge large parts of the planet into darkness for up to 10 years. But to properly quantify the effects, it would help to know exactly how big the Carrington event was. In the intense dry heat of the desert, a block of frozen water may hold the answers. This is the Desert Research Institute outside of Reno, Nevada. And these two scientists believe telltale fragments of the 1859 solar storm are held here in suspended animation. Fire locked in ice. Hydrologist Joe McConnell has a freezer full of centuries-old ice cores, cut from deep in the frozen wastes of Greenland.
The beauty of an ice core is it actually records the chemistry of the atmosphere, and so that can tell us all kinds of things.
Bruce Turatani is a space weather scientist from NASA's Jet Propulsion Laboratory. He hopes to find nitrates from the 1859 solar storm trapped in McConnell's ice.
Ice cores can help us go back hundreds of years. This opens up a whole new field of research for us.
When high-energy particles rain down on the Earth's atmosphere, they smash the air molecules apart. These recombine to form new molecules called nitrates. The nitrates dissolve in snowflakes and fall to Earth on the polar ice cap. Every snowfall adds another layer of ice. Then scientists can extract the ice for analysis in the form of deep cylinders called ice cores. In the ice core, any deep layer will have been covered by many years of snowfall. The deeper the layer, the older the year. This is a section of ice core that spans the years 1856 to 1861. It should contain the evidence of the Carrington event. And now the years melt away, releasing the chemical secrets of a 19th century time capsule. Meltwater that's ready for chemical analysis.
We're shooting up here. This is 1856, and this should, I think, this will be the winter of 1857. Okay. So January 1857. So let's see.
The all-important nitrate traces are in red and blue. If they can find nitrates in 1859, then Turutani could have hard evidence of the Carrington event.
This lab is absolutely fantastic. They can do things nobody else in the world can do. We're melting the ice, we're seeing what's in the ice, telling us about solar flares that happened 150 years ago. That's amazing.
It's not easy to find a solar storm, but a promising spike appears in red. However, forest fires can also create nitrates, so they must check for soot or black carbon.
Yeah, let's move over to the black carbon. We can see quite a large event corresponding to that nitrate. So I think it's a safe bet to say that that nitrate is primarily associated with burning.
It's a false lead. The spike is just evidence of a big forest fire from 1857. While Turutani tries to prove that particles from the sun are locked in 19th century ice, another scientist is scouring the clouds. Joe Dwyer is a professor of physics and space sciences. He's looking for particles from faraway suns that started their journey to Earth 10 million years in the past. Space weather that he believes is the trigger for an event that occurs 4 million times a day. Its name is lightning. We get energy from our sun, but energy from suns in other solar systems may be causing our lightning. Since Carrington's solar storm in 1859, lightning has killed many thousands of people. It's a massive discharge of electricity from the clouds. Thunderbolts that Joe Dwyer believes are sparked by cosmic rays from far distant suns.
Behind me is a research telescope that's designed to study the mysteries of the universe. Well, there's a mystery that's much closer to home. Lightning has currents of 300,000 amps, voltages of 100 million amps, its temperature is 5 times the surface temperature of the sun, yet we still don't know how it works. Thunderstorms produce very large electric fields. It's like stretching a rubber band really tight, and it's waiting for something to go, and you need just something to let that rubber band loose.
Dwyer is a lightning expert. He thinks that something may be cosmic rays, particles from exploding stars, the same stuff that makes CMEs.
These things come barreling down through the atmosphere, and they sort of blaze the path through the thunderstorm that gets it all going.
Every year, 100 people die in lightning strikes in the United States alone. Dwyer is on the trail of a killer from outer space. He thinks he may find it in the Arizona desert at the Veritas Observatory, the domain of an old college pal, astrophysicist Scott Wakely of the University of Chicago. Their plan? To catch it in the act.
This is a cosmic ray coming straight down the pipe.
Wow, 10 nanoseconds, that's pretty fast.
The duration of this pulse is about 1/30,000,000th of an eye blink. Wow.
Cosmic rays hit the Earth from all directions. They're tiny, subatomic particles moving at close to the speed of light. When a cosmic ray hits the atmosphere, there's a massive release of energy that smashes the air molecules apart. This air shower moves so fast, it creates the equivalent of a sonic boom, a light boom.
So if my eye were very sensitive, much more sensitive than it really is, this is what an air shower would look like.
Yeah, you'd see kind of an oblong, bluish blob appear and disappear very quickly.
The telescopes detect an average of 250 cosmic rays every second.
This is the best looking one we've seen.
For Dwyer, the critical question is what effect air showers have when they hit a thunderstorm.
These showers are occurring about 10 kilometers up in the air.
Thunderstorms are like powder kegs ready to go off. And Dwyer thinks air showers could be striking the match.
Oh, that's interesting. That's about the same altitude that lightning initiates. And so if cosmic rays actually do initiate lightning, then this is what it would look like.
Invisible to the naked eye, all penetrating, a shower of particles passing through us and into our Earth. Pencils of blue energy raining down on us every second. Dwyer believes a typical cosmic ray is born in a supernova, the explosion of a dying star. For this cosmic ray, it's the start of a very long journey.
This source in particular is a galaxy which is about 500 million light years away.
I was going to say that's far, far away.
Okay.
Lightning is really initiated by cosmic ray air showers. Think about this. Every time you see lightning and hear thunder, there's a physical connection between that lightning and a star that exploded halfway across the galaxy millions of years ago.
At close to the speed of light, the cosmic ray finally bursts into the solar system on the shores of Neptune. It's now just 4 hours from its destination. Meanwhile, in Florida, Dwyer and his team launch a weather balloon in preparation for a long afternoon of storm chasing. Dwyer is researching the physics of thunderstorms and the type of energy and radiation they contain. So his team are hunting lightning to try to capture readings that will reveal what's triggering it. Barreling past Jupiter, the cosmic ray is just 43 minutes from Earth. Dwyer spots possible thunderclouds on the horizon.
Florida is the best place in the United States to study thunderstorms. We get more lightning strikes per square kilometer here than any other place in the country. And in fact, this part of Florida, we're in southwest Florida, is really the lightning hot spot of the country. A little south of Sarasota on the Gulf side, that's where I am right now.
We can see some thunderstorms, so what can you tell us?
Well, the stuff that you're looking at right now is just starting to go, but the best electrical activity is on the storm south of you and down in Lee County.
Eric, I'm going to put you on speakerphone just a second. Definitely we can see what looks like some rain straight ahead, some decent cloud bases, but no sign of lightning yet.
There was a brief episode of lightning at about 5:15, just right kind of where you were.
Okay, by Fort Myers then, right?
You want to get down there as quick as you possibly can. I'd get off on the exit just north of the river there.
All right, so I'm going to take this north to 17, right? Yeah. Okay, so hopefully we'll pass right through that thing up there.
A massive electric charge collects overhead, like tension building in a rubber band. It just needs something to make it go. Dwyer homes in on the storm, while the cosmic ray passes Mars, homing in on planet Earth.
Hey, what's up? Can you hear me?
Yeah, hello.
Yep, I'm here.
It seems like the storm's moving away from us, but we're under the anvil.
I mean, it'll work out for you. There were some positive cloud-to-ground strikes.
I hear some thunder, so...
The storm that we're talking about is starting to come down in intensity and starting to move offshore, so the day may end soon.
The cosmic ray smashes into the Earth's atmosphere and explodes into the Florida clouds. Only they're not in quite the right place to catch it. Today's storm chase has been a lightning strikeout. But if Dwyer's right, a star that exploded 10 million years ago, long before man walked the Earth, can still kill a man today. Weather on Earth controlled by the explosion of distant suns. But an explosion on our own sun threatens much more deadly consequences. A coronal mass ejection threatens everything in its path. And until we understand the mystery of the sun's corona, where CMEs come from, we can't predict when they will happen. The problem is, the sun's fiery brightness keeps the corona hidden from sight, except during a total eclipse. In China, the longest total solar eclipse of the 21st century is at hand. It won't be surpassed in duration until June in the year 2132. Totality here will last for almost 6 minutes, exposing the sun's corona and enabling study of this breeding ground for coronal mass ejections. This will be the 49th eclipse recorded by astronomy professor Jay Pasachoff. Pasachoff's chosen location is in the mountains near Hangzhou, over 900 meters above sea level, and above low-lying smog that could impair visibility. But with just minutes to go, it's looking like cloud cover could ruin the main event. Hoping against hope, Jay Pasachoff keeps his team focused. As thousands count down to the total eclipse, astrophysicist Stuart Clark paces the expectant crowd at the foot of the mountains.
Now you can start to feel that the light is actually starting to go.
He's on the banks of the Qiantong River, where he's a guest speaker on an eclipse tour.
We'll see it go very dark very, very soon, and then hopefully just for a gap in the cloud, and we'll get to glimpse the corona. At least we can say we've been under the shadow of the moon for the longest eclipse of this whole century.
The sun is brighter now. It's clearing. 32? Yeah.
At the last minute, clear skies. The sun smiles on Jay Pasachoff.
Filters off.
3, 2, 1.
Diamond ring. Filters off. Corona. Diamond ring.
The moment of truth. The sun is eclipsed by the moon. Pasachoff's team now have just 5 minutes and 36 seconds to unlock its secrets. They're trying to find out why the corona is so much hotter than the sun's surface, where its power comes from. Most of their recordings are done through photography, and they discover something out of this world. The cameras search for faint ripples of brightness moving through the corona, possible evidence that its searing temperature is generated by waves. By converting these waves to sound, scientists can listen to the song of the sun. This is the sun's searing breath, hot enough to spit a chunk of the corona all the way to Earth. The waves start in the hot, dense gas near the solar surface. They wash across it, growing in size with crests millions of kilometers high. Then, like ocean breakers crashing on the beach, they dump vast amounts of energy into the corona, heating it to 2 million degrees Celsius. There is a way to hear the mighty solar ocean. These waves may be the hidden source of the corona's energy. If that's true, it can help them unlock the secrets of the corona, birthplace of CMEs. Then the spell is broken. All too soon, the diamond ring reappears.
Diamond ring.
Having revealed the corona in all its glory, the moon goes on its way. Pasachoff and his team have taken one more step on the road to understanding the corona's hellish temperature. Down at the river, the eclipse was less of a success. Cloud cover obscured the sun and its glorious crown. But the crowd is not disappointed, because the eclipse was only part of the spectacle they've come to see. The Qiantong River is one of around 100 in the world that has a tidal bore. It's a natural wonder, an extraordinary surging tidal wave that travels upriver against the current.
Now we're just ready to see the tidal bore.
The unusual shape of the river mouth creates the phenomenon. It funnels incoming tides into the shallow, narrowing river. The tides are created by the gravitational pull of the moon. But in an eclipse, the sun and the moon act together, and the pull is even greater.
Today, for the eclipse, with the moon and the sun in precise alignment, you get the greatest gravitational pull that you can possibly have on the Earth. So today, we're anticipating quite a big one.
About 90 minutes after the eclipse, the river waters start to race. It's the world's largest tidal bore. In past years, it's reached heights of over 9 meters, and it can travel roughly as fast as a galloping horse at speeds of up to 40 kilometers an hour.
The situation for achieving a tidal bore is that we have a fast-draining river that's moving into the East China Sea. But the river is draining faster than the tide can actually move up it.
As the waters build, they're not ebbing away, and a giant wave is generated that then appears to change the direction of the river's flow.
So the tide effectively stalls, and it builds up more and more energy and more and more water until eventually it overcomes the draining of the river and then bursts up in this single tide.
Clark has borne witness to the physical power the moon and sun have over the Earth. Today in China, the effects were benign. But what if the sun's mood changed? How can we predict the impact of a coronal mass ejection, like the one that Richard Carrington saw in 1859? In a desert lab in Nevada, NASA scientist Bruce Turritoni is looking for clues in a block of ice from a century ago.
I am very excited. I'm on pins and needles right now.
He's trying to find the telltale chemicals left behind after a solar storm hits the Earth. So far, all he's got is evidence of a massive forest fire from the mid-19th century. But he's determined to keep looking for the Carrington event of 1859.
Hey, look at that spike. There's a spike in the nitrates. Is that the solar flare?
Well, it could be. It's occurring at the right time of year.
McConnell and Turritoni spot a big nitrate spike in September 1859.
There it goes.
They check for carbon, but it's clean. This is no forest fire.
That's the flare. Baby! Whoa, whoa!
Ice core experiments like these suggest the 1859 storm was around twice as intense as any solar storm ever recorded. It's a vital way of analyzing the solar storms of the past and a benchmark for storms of the future.
Well, I think you can revolutionize solar physics if you can find the solar flares that happened in the ice core data.
So far, scientists have examined ice cores from a couple of hundred years, but no one has found a bigger storm.
Now, there's absolutely nothing to say that another 1859 storm can't happen again. So the big focus is trying to work out how often they come about. And it seems as if it's once every several hundred years, perhaps once every 1,000 years. But right now, one could happen tomorrow.
The CME of Stuart Clark's imagination is about to impact the Earth. In Washington, D.C., a meeting held behind closed doors is wrapping up. A star chamber of scientists and policymakers discussing new research that paints a solar storm as the biggest natural disaster imaginable. one that would turn America into a third world country.
I think within a matter of a few days, there will be a general desperation situation that people will come to and not understand that why haven't things been restored.
So what are we talking about? Lawlessness, breakdown of society? How bad does it get?
Well, it seems to me that this is the kind of event that could suddenly take a very advanced society back to a much
to the 19th century.
If a massive solar storm hit our planet, the first evidence for most of us would be a spectacular light display in the skies, a sign that it's already too late.
The first thing you'd know about this taking place is that the aurora would burst into the sky. They would come from the north if you're in the northern hemisphere and just engulf the sky in what essentially looks like flames. So this blood red light. We're most vulnerable with the power grids today. They have these huge power lines that are just there waiting really for the aurora to put current into them. So the electricity induced by the aurora into the power lines comes barreling into the power station, and the transformers are simply not designed to cope with that much electricity. And it melts them, literally melts them. So the power grids these days work at peak efficiency, which means that there's no redundancy in the system, so no spare transformers, hardly any spare lines. So as soon as you start losing transformers, there's nothing you can do to get around that problem apart from rebuild them.
In 1859, the sun gave warning that it has the power not only to sustain us, but also to destroy us. So far, that warning has gone unheeded. For now, we can only hope that the sun decides to smile on us for a little while longer.